Hi class, let's take a look at example 3. In example 3, it's similar to the previous ones, except that it's basically saying in between, so you're not going to have the infinity on it. So if you were going to actually state this as a regular problem, you would just say, well, let c equal to a random variable. And then the probability of this one, it's going to be that c is in between the following. Now, I'm just going to jump to less than or equal or greater than or equal, since the random variable happens to be continuous. So in between actually includes the edges. So that would mean that it includes 2.56 on the right. So 2.56. And then on the left hand side, it's going to include the negative 1.22. So this is 0. And then 2.56, I'm just going to say that that's here. And negative 1.22, not to scale, but approximately there. So technically, the area that we're going to find, or the probability, it's going to be between those two. So let me show you the fastest way to evaluate this one, and that's going to be with the calculator. So normal CDF, this one, we're not going to have to adjust with a large value to include the infinity. You can just go directly to negative 1.22, and then the upper bound is 2.56. So the area between those two c-scores, it's 0.8835. So approximately 0.8835. And once again, let me display the actual code. Normal CDF, negative 1.22 to 2.56. Don't modify the 0 and 1. We'll be modifying that once we do the applications of the normal distribution and standard normal distribution. Okay, so let me show you how to actually find this using the table, since you may be asked on some of the problems to use the table as opposed to use technology. So you would still declare the value as z is a random variable, and then your c-score, it's going to be between 2.56 and negative 1.22 for the statement that we're going to look into. Now, here's a minor problem. Your distribution in terms of the table only gives you the area to the left, and it goes all the way to the left, so all the way to the negative infinity to c, negative infinity to c. So if we're going to do this using the table, you have to find first the maximum area minus the minimum area. So this will be my max area minus technically min area. So it's going to be translated as follows. And you can directly just change the statement to the following. So the maximum area is going to occur at 2.56. So you would just change it to the probability of z less than or equal to 2.56. And I'm setting it as less than or equal, so we get the entire area to the negative infinity, minus the probability of z is less than or equal to negative 1.22. Now, let's first find this area on the table from negative infinity to 2.56. So on the table, 2.56 is in the positives. So 2, it's going to be here. So 2.5, and then the 6 value, it's going to be here. So 2.56, it's 0.9948. So this is going to be 0.9948, and let me double check 2.56, so 2.5, and then the 6 value, it's here, 0.9948. and then minus the negative 1.22. So on the table, the negative 1.22, it's going to be negative 1.222, it's here, 0.1112. So 0.1112, evaluate that. And we're getting, this is what I'm getting from the calculator, that this is technically approximately, because it's a value, 8836. So 0.8836. And we differ a little bit. Let me double check if I didn't mess up the rounding. The rounding, negative 0.22, 2.56, 8835. It doesn't round to 6. Let me once more check the values from the table. So at 2.56, 2.5, and then the 6 value, it's here. So 2.56. So that would be 0.9931. Oh shoot, I did mess it up. So 2.56, it's 0.9948. Oh, never mind. So hold on, let me highlight it. So 2.56 is this one. So 0.9948. So 0.9948. Okay, we're good on that one. And then the other value was negative 1.22. So negative 1.22, it's here, 0.1112. So 0.1112, and let me double check that. 0.9948, 1112. No, that's fine. It's just, I don't find any errors from the table. It's just a little bit of rounding error because of the table approximations. So that would be it for this one. So in terms of what it represents on the actual sketch, from negative infinity to 2.56, and let me write it in a different color, you technically have, well, 0.9948 area, and then from negative infinity to technically negative 0.22, negative 1.22, you have 0.11, and then technically 12. So in order to just get the area in between these two z-scores, you subtract from the maximum, you subtract the minimum, and that's just going to give you the shaded region, which happens to be, well, the 0.8835.